Whether you are exporting a single asset or an entire scene, there are a few important things to know to avoid common issues and keep your workflow smooth. And if you didn't know, we also have an Unreal channel which is packed with great content. As you can see, we post new videos every week, and it's a great way to go deeper into the topic we are talking about today. Alright, so today let's talk about exporting a mesh or multiple meshes, like a full scene, into Unreal. We are going to look at the different things you need to consider and keep in mind when handling this process, which can sometimes get a bit tricky to manage. We also go over formats, what's the best formats to use for Unreal, and how to properly handle materials as well during the export and import workflow. Just a quick side note, if you're into Unreal 2, we also have a dedicated channel for it, and it's honestly packed with great content. We put a lot of time into it every week, so if you want to connect the dots with what we are doing here and dive deeper, I really recommend checking it out. So the first thing that you really need to understand is the origin of the mesh you are going to export, because this is where a lot of mistakes and issues can happen when exporting to Unreal, and it's actually the same for other GCC tools as well. For example, here you can see this object has its origin perfectly placed at its center. So in Blender, you would expect that when you export it to Unreal, the gizmo should also appear here. But if I jump into Unreal and select this mesh, you can see that the gizmo, meaning the origin of the mesh, is actually located somewhere else, and not really where I expect it to be. So why does this happen? And this is a really important concept to understand and keep in mind. Blender handles origin in its own way. So if you press N on your keyboard and go into the item panel, things can get a bit confusing at first. You will see the 3D cursor, which is a tool in Blender used for a lot of operations. Here, if I go into the view settings, you can see that the 3D cursor is located at the world origin, meaning 0, 0, 0. Now the object itself has location values. And in Blender, the origin is essentially the pivot point relative to the object transforms. What you are actually seeing is the offset between the object's position and the world origin. So the object might have value on X, Y, and Z, but its origin is defined in relation to their world space. What Unreal does, however, is different. When you import a mesh, Unreal will by default read the world origin. So regardless where your origin is in Blender, it won't necessarily be preserved the same way. Instead, Unreal will place the pivot based on its own interpretation, often snapping it to the world origin or recalculating it during import. Now, when we are working with a large scene, this can actually be helpful. If you export everything together, all the elements share the same reference space, which makes it much easier to manage, move, and never scale everything consistently. So the main thing to remember before exporting anything from Blender to Unreal is that the origin you see in Blender is not always the same origin that Unreal will use. What matters is how that origin relates to world space and how the engine interprets its own imports. So to correct that, there's basically two main ways to handle it. The first one is quite straightforward. You simply grab your elements and place them so that they are correctly aligned to the origin of the scene in Blender. You can also automate part of this workflow by right-clicking, going to Snap, and using options like snapping the selection to the cursor. From there, you can adjust the position more precisely, and you can also change the origin directly using the right-click menu and choosing the option you need. The idea here is to make sure everything is properly centered or placed exactly where we want it before export. That way, when you render or bring it into Unreal, everything behaves as expected. The second approach is to handle it after export, which is often what you want when you're dealing with a full scene that you've already laid out and organized. In that case, after exporting everything, you might realize that you want to reposition the pivot or the gizmo to better match how the assets should behave. And for that, Unreal actually gives you a really useful tool. In the modeling mode, you can go into the X-Form tool and use something like the Edit Pivot option. Once you activate it, you can redefine the pivot position based on presets. For example, if I choose center, with just one click, it will automatically move the gizmo to the center of the mesh, effectively giving you a new pivot point. You will also get a warning message telling you that this is modifying the core assets in the content browser, so you need to be careful here. But the advantage is that you have a lot of flexibility. At any point, you can decide to reset or adjust the pivot again, including going back to something like the world origin if needed. Once you accept the change, your mesh now has a properly defined origin, which makes it much easier to work with inside Unreal. For scale, you can actually adjust it either during export or directly on import inside Unreal. You can also change the unit if needed from this panel here in the scene properties. Under units, you can switch it to something like centimeters. Just remember something, that Blender by default works in meters, while Unreal will work with centimeters. So having a consistent scale and unit setup between both software will make things much easier to manage when you import your assets. In my scene here, for example, I had to slightly scale up the entire scene because at a scale of 1, everything felt a bit too small. In some cases that can make sense, especially if you're working with a small or stylized character like a cute little asset, for example. However, for proper lighting, correct shadow behavior, and to avoid potential artifacts, it's really important to stick to a proper real-world scale that matches Unreal standards, which is based on centimeters. So now let's talk about export settings, formats, and the kinds of issues you're likely to encounter. In this case, I didn't actually build this scene from scratch, so there are quite a lot of things going on. It's not necessarily because there are mistakes or problems, it's just that it has originally meant to be rendered inside Blender rather than exported to another engine like Unreal. When it comes to exporting, there is a real preparation step you need to go through, and you will often need to adjust quite a few things before getting a clean result. For example, if you go into this viewport display option and enable face orientation, you can immediately see that some faces are inverted. That can become a problem once you import the mesh into Unreal because flip normals will often show up as broken shading or invisible faces. You can actually see similar issues here as well. And if I jump back into Unreal, by default this character right leg has inverted normals. The interesting thing is that this isn't always obvious inside Blender until you properly apply transform or check the mesh under the right conditions. Sometimes you just need to apply transform first to properly visualize the final state of the geometry, including any flipped normals. And this is really part of the final preparation workflow before export. You want to make sure everything is clean, proper UVs, transform correctly applied, normals properly oriented, material set up in a consistent way, and so on. So now, if we talk about formats, you can simply select everything and export it as is using an FBX format. In most cases, you can leave a lot of the settings at their default values and it won't change much. Because at the end of the day, as I mentioned earlier, the most important part is still the preparation of your scene. In my case here, using FBX actually gave me a pretty solid result. I did notice a slightly different scale compared to some of the other formats we are going to look at just after, but overall it was quite stable. The main thing when exporting your mesh is to understand your pipeline and where you want the process to end, especially between Blender and Unreal. And this is a really important point when it comes to importing, exporting, and doing a round trips between different tools. So now let me show you two examples. This is a scene imported through an FBX format. I simply select everything and export it without doing anything fancy. It did bring in the sofa, some materials and a few accessories, but not everything came through perfectly. And that's really the key things to understand when exporting and importing assets. You need to know where your work is going to end up. If your goal is to do lighting, rendering or look dev inside Unreal, then you should try to build your materials in Unreal as early as possible. Otherwise, you will end up duplicating work on both sides. For example, in Blender, if I select this object here, you can see we have a fairly complex node setup for the material. But this kind of shader setup won't translate very well into Unreal. Even though Unreal now has a much better interchange system, there will still be differences and mismatches between the two material systems. And if you're relying on texture, you will often need to bake them properly inside Blender so you can reproduce the same result in Unreal. At the end of the day, exporting materials between softwares is always a bit of pain because you will never get a perfect one-to-one match. That's why it's usually better to create your final look dev material directly in the software or engine where you plan to render. The other format I want to show you is GLTF. With GLTF, when you import it, you can see that textures, static meshes, and materials are generally preserved in a much cleaner way, with more information carried over during import. If I open the second map, this is what I get from the GLTF import. There is definitely more information compared to FBF, and even textures and images come through correctly. It's still not perfect as you can see here, but it's noticeably better than the FBX import in terms of material and texture handling. Some elements, like the ears for example, still have issues with the shading or surfaces capturing, so Unreal struggles a bit to interpret them correctly. But overall, GLTF gives you a much better base to work from when importing complex scenes. To keep it simple, you will always need to manually adjust things when converting and importing scenes or meshes between different DCCs or software. One of the biggest improvements you will see is that with the GLTF, you retain more reusable data and Unreal is able to reconstruct materials more intelligently. Inside Blender, when exporting as GLTF, you also get a range of operator settings that let you control exactly what data you want to include in the export. And in Unreal, when imported GLTF, you get a similar import menu to FBX. With a newer importer, especially from Unreal 5.5 and onwards using interchange, you can automatically generate material instances. So instead of rebuilding everything manually, Unreal will create materials instance for you. With exposed parameters, you can tweak directly. You can simply adjust things like color and reuse the same materials across multiple assets, which makes iterations much faster. It's a bit improvement compared to older workflows and shows how much progress has been made in Unreal's import pipeline recently. And that's it for today, guys. I hope you enjoyed this video. Don't hesitate to leave a like, subscribe to the channel, and I see you in 2 weeks for a new one. Don't forget to support the Unreal channel too, and ciao!